Yes, hello class. Welcome to another lesson that we are going to continue with oxygen. Remember to watch this video and revise some papers. I have some papers for you after all these videos. Now we are continuing with oxygen, and we are talking about the reaction between oxygen and the metals. And in this case, we are going to talk about reaction between copper and oxygen. So there's a procedure of which you are using a pair of tongs or the piece of copper tannings or shaving on a Bunsen flame. Then you are supposed to observe what happens. Then place the products in a beaker containing about 2 centimeter cube of water. Test the solution, stop mixture using litmus paper. And when you are told to use litmus paper, that means you use both red and blue litmus paper. So that is what we are supposed to do. Now, what happens here? Using tongs, a pair of tongs hold another piece of copper tanning and a Bunsen flame, quickly lower it into a jar containing oxygen. So in other words, the other one we are burning in air, then here we are burning in pure oxygen. And remember, I told you that a reaction that takes place in presence of pure oxygen is faster compared to a reaction that takes place in air that is mixed with other gases. Then place about 2 centimeter cubes of water, swirl, test the solution, stop mixture using litmus paper. Then you have to place the products in a beaker containing about 2 centimeter cubes of water, test the solution mixture using litmus paper, and then that is repeated. Now, these are the observations which you are supposed to make. In air, when you burn it in air that is containing oxygen, nitrogen, and other gases, you find that copper shaving is going to burn with difficulty. It's going to burn with difficulty with a green flame. It's going to burn with air, and after burning, it's going to form a black solid. And this black solid is copper oxide. Copper oxide is one of the black solid we are dealing with in your curriculum. So it's going to produce a black flame. And now, when you test, you take that black solid, you insert, or rather you put into a beaker containing water. It's going to form a solution, which is going to be copper hydroxide. Now, when you take a blue litmus paper and put inside this solution, the blue litmus paper will remain blue, and red litmus paper will turn red. And red litmus paper will turn faint blue. And this is just an indication that the solution we are dealing with here is kind of basic. The solution is basic. Then in pure oxygen, copper tanning burns with less difficulty because this is now pure oxygen. The first one, which was air, was burning with difficulty. But here, the difficulty has been reduced because we are dealing with pure oxygen. And the flame with which it's going to burn is going to be green flame, and a brown solid is going to be formed in this case. Then blue litmus paper remains blue, red litmus paper is going to be faint blue. Explanation here is copper burns in air forming a black copper oxide. Then the equation which we are going to have here, we are going to have copper burning in oxygen, pure oxygen, or in air. Either way, it's going to form copper 2 oxide. So now, what you are supposed to know is that very small amount of copper 2 oxide is dissolved in water from a weekly basis. So copper is not that soluble in water. We are going to talk about solubility of different salt in water, and we're going to look at the oxide which are soluble and the one which are insoluble, slightly soluble, like copper 2 oxide. Now, when you take copper 2 oxide, you dissolve in water, it's going to give you copper hydroxide. So it's going to give you copper hydroxide. That's what we are going to end up with there. Now, that's going to mark the end of a reaction between oxygen, and metals. Now, one thing you need to notice, or that you should have noticed, that when metal react with oxygen, they are going to form oxides. Metal reacting with oxygen is going to form oxide. And the oxide, when they are dissolved in water, when these oxides are dissolved in water, they are going to form hydroxide. And this hydroxide which are going to be formed are going to be basic or alkaline. So that's something you should have noticed. They are going to be basic or alkaline. So that is the part of metal. Now we are going to go to non-metals and see whether the kind of oxide you are going to produce, and this oxide is, we are going to see whether they are going to be basic or alkaline. So now the following experiments show the oxygen reaction of the non-metal with oxygen and air. So one, you are going to consider carbon. Now carbon, one burns in limited oxygen, is going to give us a different product. When it burns in excess of oxygen, it's going to give us a different product. So using a pair of tongue or a dry piece of charcoal. Charcoal is carbon. Charcoal is carbon. On a Bunsen flame, observe what happens. Place the products in a beaker containing about 2 centimeter cube of water. Test the solution of mixture using litmus paper. Now, part B, using a pair of tongue or hold another piece of dry charcoal on a Bunsen flame. Quickly lower it into a gas jar containing oxygen gas. Observe what happens. Place about 2 centimeter cube of water. Swirl. Test the solution or the mixture using litmus paper. Now, observation. Carbon chars. Charring, turning black, then burns with a blue flame. So it burns with a blue flame. Colorless and odorless gas is going to be produced. So this gas can be either of the two, one carbon dioxide or carbon 2 oxide. We are going to see as we proceed here. When the solution form turns blue litmus paper paint red. Now you see this is a non-metal burning, and we are going to have the stage of having the blue litmus paper remaining blue. In this case, blue litmus paper is going to turn red. In other words, that should be telling you that the kind of solution we are dealing with here is acidic. While the red litmus paper, now we expect the red litmus paper to remain red. So the red litmus paper will remain red, while the blue litmus paper is going to turn to paint red. So that should be able to tell you that this gas is, or rather this gas is, when dissolved in water, is going to form an acidic solution. And the gas which is going to be produced here is carbon dioxide. Carbon dioxide. Carbon burns in air and faster in oxygen with a blue non-sooty or non-smoky flame, forming carbon dioxide. Carbon burns in limited supply of air. When it burns with limited supply of air, with a blue flame, produce non-sooty or non-smoky, and this one, when it's limited supply of air, it should be producing carbon dioxide. Limited supply of air should be carbon dioxide. But when it burns in excess air, it should be carbon dioxide. Now, carbon dioxide gas dissolved in water to form rich acidic solution of carbonic acid. Now looking at that one, when it burns in excess air or oxygen, carbon plus oxygen is going to give you carbon dioxide. But now when you burn carbon in the presence of oxygen, and in this case limited air or limited oxygen, you are going to form carbon 2 oxide. Carbon 2 oxide. Now when we take carbon dioxide that was formed, to dissolve it in the water, is going to form a weak carbonic acid. That's why you find that the litmus paper is going, the blue litmus paper is going to turn into faint red. because we are dealing with a weak carbonic acid here. Now, when we burn sulfur, what happens when we burn sulfur in air? Burning sulfur in air procedure using a deflagrating spoon, place sulfur powder on a Bunsen plate. Observe. Place the product in a beaker containing about 3 cm³ of water. Test the solutions of mixture using litmus paper. Using a deflagrating spoon, place sulfur powder on a Bunsen flame. Slowly lower it into a gas jet containing oxygen gas. Observe. Place about 5 cm³ of water. Swirl. Test the solution using litmus paper. Observation. Sulfur burns with a blue flame, just like carbon. Gas produced and has a pungent smell, and this will be sulfur 4 oxide. Solution formed turns blue litmus paper paint red. And doing that is turning blue litmus paper into paint red. Should be telling you this is also a weak acidic. This is a weak acidic solution. And of course, we are expecting the red litmus paper to remain red. Now, explanation: sulfur burns in air and faster in oxygen with a blue and non-sooty orange smoky flame, forming sulfur 4 oxide gas. Sulfur 4 oxide gas is dissolved in water to form a weak acidic solution to sulfuric 4 acid. Now, here is the question: sulfur plus oxygen for sulfur 4 oxide. Then sulfur 4 oxide, if we dissolve it in water, is going to form sulfuric 4 acid. Sulfuric 4 acid, which is a weak base. Now, sorry, a weak acid. Now, burning of sulfur phosphorus. Phosphorus is always stored underwater. The reason is why it is being stored underwater: when it is exposed to the air, then rather to air, it reacts. So it's burst into flame. Now remove a small piece of phosphorus from water. That means where it was stored, and using a deflagrating spoon with a lid cover. So you take the deflagrating spoon with a lid cover. That means you are trying to stop it from from reacting with air before it reaches its destination. Place it on a Bunsen burner flame. Observe. Carefully put the burning phosphorus to cover a gas jar containing about 3 cm³ of water. Test the solution of the mixture using litmus paper. Now, procedure B: remove another small piece of phosphorus from water and using a deflagrating spoon with a lid cover, place it on a Bunsen burner flame. Then slowly lower it into a gas jar containing oxygen gas, about 5 cm³ of water. Observe. Swirl. Test the solution of mixture using litmus paper. Observation: phosphorus catches fire before heating in a Bunsen flame. Now you understand why it's always stored underwater. Before even catching that fire, it has already burst into flame. Now, dense white fumes of gas produced that has a pungent smell, and this gas is choking. It's a choking gas. Solution formed turned litmus paper paint red. Then litmus paper remains red. That should be telling you that it's an acidic. Phosphorus is stored in water. On exposure to air, it instantaneously fumes, then catches fire to burn air, and it burns faster in oxygen with a yellow flame, producing dense white acidic fumes of phosphorus 5 oxide. Phosphoric acid is produced when you dissolve phosphorus 4 oxide gas to form an acidic solution. So these are the questions for that. Now, so we are going to put a stop there. Next time we are going to discuss about the activity series. Thank you.